And the idea there was that output depends on what people spend. And what people spend depends on their income. But output and income are the same thing. So we have output on the left-hand side, but we also end up with income on the right-hand side. And it's not the same for them, but we know for the economy as a whole it has to be the same. So they're making their decisions just based on their income. But in equilibrium for the economy as a whole, they have to be the same. And so we've got y on both sides of the equation. We've got one equation, one thing that we don't know. And so we can solve for this for y. And this is what we get. Okay? In this particular model, people are going to memorize this because that is the way people are. But it is not a good idea. I can change the model. You'll get a different formula. In fact, I will not give you exactly the same one because I want you to know whether you understand it rather than whether you tattooed it on your hand. And so, but it is telling us something, right? It's telling us that output is going to depend on autonomous expenditure times a multiplier, times this thing. And we're thinking that this multiplier, just looking at it here, is in the realm of 20-ish here. Right? Because if we think that, people were asking me this after the class yesterday, so let me do it here. If we're thinking that c, little c, is more or less 0.95, that you spend 95%, then 1 minus little c is more or less about 0.05. And we know that there's 25s in 100, right? So this is 5%. There's 20 of these. So 1 minus c is about 1 over 20. 1/20th of a whole, right? And so if y itself is going to be 1 over 1 minus c times e, that's equal to 1 over 1 divided by 20 times e. And so this part here, this multiplier part, is 1 over 1 over 20. But of course, if you divide something by a fraction, you just flip it over. And so that is 20, or 20 over 1, for those of you keeping track at home. So it's more or less 20 in this particular model. Now we can make the model more realistic, and that typically will make the multiplier lower. It'll make it less of a big thing, but that's more or less what it is. Okay. So that's our multiplier, and this is important because this autonomous expenditure is a thing that is likely to change a lot because people get, they think that investment conditions are good, and so they invest a lot. Or they think that next year is going to be bad and they cut their investment down. It's also something that we can control through government spending because government spending is part of this, right? G was in that E thing, right? It was in there somewhere. We can see it right here. Foreigners are going to like or dislike our products more or less. That's likely to change. And so it's something that's likely to change a lot. And then any of those changes in autonomous expenditure are going to be multiplied by this multiplier and have a bigger effect on output. And so it's interesting in that way. Now, what we don't have yet is the real story for why this is, but bear with us. This is one way to do it. But of course, we have 3 ways to look at all of these things, right? We have the math, we've got the graphs, and we've got the story. So we want to do the graphs and the story, right? Here's the math. It is what it is. Okay, and there's me going through it in my sloppy little handwriting. So here's our graph. Right, so we have our graph, and we're just taking our planned aggregate expenditure line that we had before and our equilibrium line, this 45-degree thing, and we're putting them together, and we say both have to be true at the same time. So people have to be spending the amount that they want. That's this planned aggregate expenditure line. That's saying I look at my income. Here, we're thinking of this as income, and I decide how much to spend. Right? And if I have no income, I spend out of my savings, and we spend this much. And if I have higher income, I spend more by this marginal propensity to consume. So if I have 1 more income, when my income goes up by 1, my spending goes up by C, 95 cents, something like that. Right? And so we get this line going up. Importantly, this line has a slope less than 1. Right? It has a slope less than 1 because the marginal propensity to consume is less than 1. Right? And we have this here, which is this is equilibrium. That output has got to be equal to people's spending because we have this barbershop metaphor. People are coming into the barbershop. Our output just happens because they spend. So the amount of haircuts that we give are going to be equal to the amount of haircuts people want to buy. And so we have to be on this line as well. And there is a point where they cross. This is the way of economics. There's two lines, and there's a magic point where they cross, and this is what's going on. And so this is our prediction for equilibrium output. Okay? This equilibrium exists because this aggregate expenditure line has slope less than 1. You can imagine, for example, if the marginal propensity to consume was 1, exactly 1, then the planned aggregate expenditure line would be 45 degrees as well, and they would never cross. Okay? And we saw that in our math when we divided by 1 minus C. Right? To do that, it only worked if C wasn't 1. Okay? So we can see that in the graph, and we can see that in the math. It's the same thing. Okay? So here we have equilibrium. Now what we haven't seen yet is the multiplier here. So we want to see the multiplier in the graph. Right? The big punchline of this whole thing is the multiplier. And so in everything, in the math, in the graph, in the story, you want to be thinking, how do I understand the multiplier from that? Right? Because that's what we're going to learn from this. The equilibrium output is neither here nor there in a way, because we could just like go out and see, look, there's output, so there must be equilibrium output. We haven't learned anything just by finding equilibrium output, other than, aren't we clever, standing how a model we can solve. But we haven't learned anything about the economy just looking at this graph so far. Right? It becomes interesting when you say something changes, what happens to the economy. Okay. So suppose something changes. And this is the typical theory sort of question that you get on exams. And it's actually why theory is useful, is because, it's all well and good to say we have equilibrium, but of course, the real world is a better example of what's going on in the real world than our little toy model just in and of itself. But now that we have the model, we can ask it questions. We can say, given that this is the way that the world works, and of course we've simplified the world ridiculously, but if the world just worked in this simple way, what would happen when something changed? So a typical theory question will always be, we're starting out in some kind of equilibrium of this sort of world, this sort of model. And then something changes. What is the effect of that change and why? Okay, that would be a typical question. Because that's what theory is for us to speculate and to think, how does the world get affected by changes in the environment? Right? And so that we can understand how those changes work. Now, of course, we're simplifying things, so we're not going to get the full story. But if we were good at setting up our model, we will learn something about the world in this process. Okay? If we're bad at setting up the model, we'll learn something wrong about the world, and that's not helpful at all. So there's, you have to be careful. But if we buy this, that this basic story that people buy depending on their income, and production happens based on how much people are buying, those two things, price is fixed in the short run, all that, then hopefully we can learn something, right? So what happens if something changes? And here we're going to have people become pessimistic about the future. They're going along, everything's fine, and then all of a sudden they say their sports team loses, and they say the world is crap, it's all going to hell, and Dublin can't even win the thing, and so therefore everything looks negative, and they think next year is going to be terrible, I might lose my job. Okay. Fine, they're pessimistic, they got a bad week, but they start being pessimistic, they're thinking that they're going to lose their job, they're not going to spend as much now because they need to have that nest egg for when they lose their job. Right? So all of a sudden, they start spending less. Autonomous consumption is going down. It is also likely that autonomous investment goes down. Right? Because why are you investing? Why are you building a new factory? It's because you hope people are going to buy it next year, but now you know next year is going to be terrible. So maybe not build the factory now. Right? So you have this expectation about the future that affects your autonomous spending now. Autonomous spending now goes down. Okay? So at any level of income, they're going to spend less. Because this is not spending going down because they're poorer. It's spending going down because they think they might be poorer later. Right? So current income could be just the same, but at any particular income they had, they're going to spend less than they did before. Okay. So what this is, here we go. Yeah. Let me instead, I think it's not as helpful as looking at these graphs this way. Let me sort of draw them out. We go back a little bit. Okay. So I'm just duplicating those graphs. So here we've got Y, income, output, and here we've got planned aggregate expenditure, right? And we've got, I'll do it in the same colors just to be fun. Y equals planned aggregate expenditure. That's our 45-degree line. And we've got planned aggregate expenditure itself. That is our C plus I plus G plus net exports. Now, we've said that they become pessimistic about the future so that at any level of income, they spend less than before. So what's going to happen is this curve is going to shift downward. And it's going to shift downward in a parallel way. So I'm going to make it a really big shift here. And it's not super parallel. Let me try again. Parallel, parallel. Okay. That is, if autonomous expenditure fell by 10, this distance here is 10, and this distance here is 10. At any level of income, they decrease their spending by 10. Okay? And so, very clearly, output goes from here down to here. So that's the overall change in output. And what we want to see is the multiplier. So what we want to see in the graph is that output fell by more than 10. Okay? That's where we're going. This is the thing that we're looking for. So yeah, is there at the graph, like how do you tell the output fell more than 10? Well, output and expenditure have to be the same, right? So before we were at this point, right? And so my original y, y1, has got to be equal to this, which is y1 as well, right? Because we're on the 45-degree line, that's got to be the case. And then output fell to y2. But notice that if output fell by exactly 10, well, 10 is the amount of this shift, right? So this amount here, this move from y1 to the green dotted line, that is 10. So in fact, output fell by more than 10, right? Because you can see here, 10 is going from y1 to the green thing, and then output actually went out all the way down to y2. So output fell by more than 10. Okay. Okay, so here it puts numbers on these things, right? It says we've got, our original one was 960 plus 0.8y, so there was 960 autonomous spending, and that fell to 950 plus 0.8y, and you can do the math and get the numbers, 4,800, 4,750. You got the formula, right? We solved for that. You can do that. Right? It's autonomous spending times 1 over 1 minus c gives you output. In this particular model, we solve that. So these numbers come from there. Now, one thing about this graph is this graph is telling a story. And this graph is telling a story about where a recession might come from. And so the story it was telling, we can go back, we can do this. The way it's drawn here, well, not here, is like this is the whole model. This is everything we put into the model. And this model, in a way, doesn't say anything about recessions or booms because there is nothing about potential output in this story. Right? Nowhere when we were doing the math or when we're doing the graphs or anything did we reference this potential output, this normal level of output. It's just not there in the story. And that's problematic, right? In the sense that we kind of think, like we could reverse this. What if people became optimistic about the future and output went up? Well, that's fine, but maybe we only have so much capacity to make output. Maybe we're running at capacity and all our factories are full and all of our people are working. Where does that output come from? Right, we have in our story, you come into the barber shop, we're going to cut your hair, right? And there's no sort of output constraint in our barber shop. If nobody comes, we don't sell any. If everybody comes, we cut all the hair. And that's fine for a Great Recession sort of thing, Great Depression story, which is where this was invented, right? Everyone's not. But if you're in normal times and maybe your barber shop is full and then you don't have chairs for the guys or you don't have workers to cut the hair, it becomes more problematic. Okay, so that's something really important we've left out. Okay, so there's nothing about potential output, normal level of output, our capacity to produce stuff that's in this story anywhere. Right? It's a horrible missing bit. Like it's clearly important, and we've clearly left it out. And the reason is, first of all, we're making the simplest model we can because it's the first one, but also because this was made for the Great Depression, where that wasn't really the problem. Okay? But here, in this, not this one, but this version, we got thrown in because it's telling a story. But it's telling a story that's not really part of the model. So it said, let's put y star in here. And let's say initially, at point E, with our original planned aggregate expenditure, initially suppose that everything was behaving normally. We were at the normal level of output, potential output. We were in equilibrium in the short run. That is, on the red line, people were buying the amount that they want. On the green line, everything was good. And then people became pessimistic. Okay? Then planned aggregate expenditure falls, the line shifts down, output goes down by more than the fall in planned aggregate expenditure. Okay? And we end up with our new equilibrium at 4,750, where output is less than potential output. And this is our basic story, at least in this model, about where recessions come from. People become pessimistic, either investors or consumers. They stop buying stuff, and therefore output is less than the normal level of output. Okay, that's going to be our sort of starting story, our beginner story. Okay. But again, there's no potential output in this model. It's just something we threw in to tell a story. Okay. What do we got here? Okay, that's what we had before. Okay, so now we want to ask ourselves, what's the reason behind this? We did the math, we saw that there's a multiplier. We did the graph, we saw that there's a multiplier. But we don't know why yet, right? There's no story here, it's just a mathematical thing. And so now we want to understand why that is. Okay. So let's suppose, so the multiplier is sort of by definition the effect of a 1 unit increase in autonomous expenditure on short run equilibrium output. So autonomous expenditure goes up by 1. What happens to output overall, right? And so if we have a multiplier of 5, which is sort of more realistic than 20, if we have a multiplier of 5, then if we have a 10-unit decrease in autonomous expenditure, output would go down by 50, just like in this model, in the example. Okay. Okay. Okay, so how does it work? So in our story, expenditure fell by 10. Autonomous expenditure fell by 10. So what happens there is people stop spending 10. And because when they're spending, they're going into our little barber shop, that is 10 less in haircuts that get produced because they stop spending 10. Okay? And if that was it, that would be it, and the multiplier would be 1, right? Because we stopped spending 10, output fell by 10. That's a direct effect. We stopped going, therefore, because we were producing on demand, that stuff didn't get produced. But clearly that's not the end of it, because the multiplier is more than 1. So what happens then? So then the barber feels poor, right? Because he used to have customers coming in and spending 10, but now they're not spending 10, and now he's just sitting there waiting for customers and no one's coming. And so now he feels poor, and he does what a poor person does. And in our story, what a poor person does, a person with low income, is they stop buying as much stuff. And his spending falls by 10 times C, right? Because his income has fallen by 10, and he reduces his spending by C times his income. Right? So his income will fall by 10, but of course, as now his spending fell by C times 10, now he used to be going to some other barber and getting his hair cut, but now he's not doing that. And so that barber feels poor by C times 10, and so he's going to reduce his spending by C times the amount that he feels poor. Right? And so his spending falls by C squared times 10. And then, of course, he was going to a barber, and that barber feels poor, and so on and so on and so forth. Okay. All right, so here's what we're doing here, and I'll walk you through this. So we're using the Greek letter delta to represent change. So this is the change in output. This is the change in planned expenditure. Right? And if we do that exact same story that I had there, what happens? So we're wondering, what is the change in Y? How much does Y change when output changes? When autonomous expenditure changes. Y is output. When the autonomous expenditure changes. Well, the initial effect is, suppose autonomous expenditure goes up. Let me do it the opposite way. People start spending more. So initially, they buy more stuff, and output changes by the change in E, right? Because that's how much more they're buying. They get that many more haircuts. That many more haircuts get produced. And then, of course, the barber feels rich, because now he has this income. This change in E is income to him. And so he's going to do what a rich person does. He's going to buy stuff. And of course, in our little stupid economy, the only stuff there is haircuts, so he gets more haircuts. But in general, he can go to the pub or go on vacation or whatever. Right? And so he's going to change his behavior by C times delta E. Right? The delta E was how much richer he felt, and C is how he changes his behavior when he feels richer. Okay? And then, of course, now he's buying more haircuts, this C times delta E. And so that next barber down the line, he feels richer as well. Right? So he feels richer by C times delta E. That's the amount richer he feels. And so he changes his behavior by C times that. And then, of course, that means that guy, he has now increased his consumption by C times delta E. And then he goes to a barber, and that barber feels rich, and he changes his behavior by C times C squared delta E. The parentheses bit is the amount that he feels richer, and then he changes his behavior by C times that. He increases his spending by C times that, and so on and so forth. And so on and so forth is an infinite series, right? This guy feels richer, he buys something. That guy feels richer, he buys something. That guy feels richer, he buys something, and so on. And so this whole thing, the change in Y is equal to delta E plus C delta E plus C squared delta E plus C cubed delta E, and so on and so on and so forth. Right? Okay. So what do we do with this? Because we're wondering, how much does Y change? And what we've got is an infinite series here. And we can actually solve this if C is less than 1, greater than 0. Okay? And that's why we didn't say just C is not equal to 1, but we actually need this thing to be small. Why? Because if C was greater than 1, it would mean I got 10 richer, I spent 20. You got 20 richer, you spent 40. And then it wouldn't converge to anything, right? It would just go off to infinite amounts of spending pretty quickly. So in order for this thing to die out and for these things to get smaller and smaller, marginal propensity to consume has to be less than 1. Empirically, not a problem, but mathematically, that's why we did it. All right. So how do we solve this? Well, one thing I can do is I can notice that all of these things have a c times them, let me factor out one c from all of them. It was a bit goofy, but bear with me. So I get delta y is equal to delta e plus c times delta e plus c delta e plus c squared delta e. And you'll notice here that, that one here is this one here. I just factored out the c. So I took a c out, and now it's just delta e, right? But it's still c delta e because it's c times the bracket. This one here became that one here. I just took a c out. This one here became that one here, and so on. So I just rewrote it, right? And I rewrote it in a particular way because of this next bit, because I can see now that this bracket looks just like this line in the previous line, right? They are, in fact, the same thing. They're this infinite series starting with delta e plus c delta e plus c squared delta e, and so on and so on and so forth. And because they're infinite, the fact that I've staggered it one sort of period, one sort of round, doesn't matter because it's the infinite series. So I can rewrite this, noticing this fact, I can rewrite this thing as delta y is equal to delta e plus c times delta y, because all of that bracket stuff is the same as the right-hand side on the previous line, and that's the same as the left-hand side on the previous line, which is just delta y. Okay. And so now I'm in business. I've got delta y on both sides. Let me put them on one side, so I get delta y minus c delta y is equal to delta e, or 1 minus c times the change in y is equal to the change in e, or the change in y is equal to 1 over 1 minus c times the change in e. And again, this is our multiplier. Okay. So it's this infinite series thing, but then it ends up being just what we had before. Remember, before we had y was equal to 1 over 1 minus c times e. Now we're saying the change in y is equal to that same thing times the change in e, which is not shocking because if the thing itself is that way, the change has to be that way as well. Okay. Okay. Now, the trouble with showing you the math, and I do worry about this, showing you, I should, like this is going to come next year. You should be aware that this is the kind of thing that you're going to be doing. But the trouble with it is that it can, because particularly people who are have had bad experiences with math in the past, is it obscures the forest for the trees. And what is the forest here? The forest is we want to understand this story, right? The story is people spend more. That creates output because of the barbershop thing. Right? That person, the barbershop guy, feels rich. He spends more as well. That guy feels rich. He spends more as well. Okay? What you should not do is memorize this multiplier, 1 over 1 minus c, because it's not, in general, 1 over 1 minus c. Right? This is just a particularly simple version of the model. I can change the model. The multiplier will be something else. But what you should be able to do is you should be able to tell me whether something makes the multiplier bigger or smaller. So if, for example, I say, now we have income tax, and so the government takes part of your income. Okay? What happens if we make that income tax rate higher? Does the multiplier go up, or does the multiplier go down? Okay, so if we go from a 40% tax rate to a 50% tax rate, does the multiplier go up or down? I don't know, right? I ask you the question like you're supposed to know, but I don't know. I didn't memorize this. I've been teaching this for a while. I've memorized loads of things, but I didn't memorize this. And so what I would do with this question is I would just sit down and think it through, right? This is the point. I would likely give you a question that you haven't seen before, and your job is to think it through. And how do you think it through? Well, you can think it through mathematically. You can solve it out, and you're good to go. Or the question is just, does the multiplier get bigger or smaller? Not exactly what it is. So now we can just think, does the multiplier get bigger or smaller? And so what do? Well, we say initially, people, initially, on the initial round, what do we have? People spend more, right? That means that many more barbershop people came into the barbershop, that many more haircuts got paid, right? That's fine. That's still the same. Now, the barber felt richer, so he did what a rich person does, which is obviously get his haircut. Perm. He's getting a perm. But now that the tax rate has gone up, he doesn't feel quite as richer as before, right? If the tax rate was low and he had more customers, he'd keep 60% of that. But now with the higher tax rate, he has more customers, he only keeps half of that. So he's keeping less of the money that he's getting from his customers. So he doesn't feel as rich as he did before, and so he's not going to change his behavior as much as before. Right? And so the multiplier will be lower. Right? Let's be in this world. If, for example, the marginal propensity to consume was 0. Okay, C is 0. What is the multiplier? Right? Now, let's tell the story. Guy comes into the barber shop. His autonomous expenditure has gone up. That's lovely. He buys some stuff. We make the hair. We're going to cut the hair. Then we feel rich. And we do whatever rich people do, which is spend 0 more. Right? Because the marginal propensity to consume is 0, which means when we get extra income, we don't change our behavior at all. So if the marginal propensity to consume is 0, the second step doesn't exist. And the third step doesn't exist, and the fourth step doesn't exist. But we can stop at 2. I mean, at the second step. The second step, the guy's not going to change his behavior at all, and therefore it's only the initial effect that's going to matter. Right? So if the marginal propensity to consume is 0, the multiplier is 1, because we don't change our behavior. It is the changing the behavior of the guy who sold you the stuff, that's what makes the multiplier. Right? So again, the multiplier story is people are spending more. That means we make more stuff. But it also means that somebody feels rich. And he's going to do whatever a rich person does. He's going to change his behavior in response to this richness. And the more he spends in response to feeling rich, the higher the multiplier is going to be. Because he's going to do it, and someone else is going to feel rich, and they're going to do something, and they're going to feel rich, and so on. Okay? So that's our story. I'm not sure that was the most coherent version of that. But anyway, that's what it is. OK, how am I doing? Yes. OK, so this is the big punchline. Like, you should understand the multiplier. And like, if you're understanding the multiplier, you're good to go for the chapter. And if you're not, you're not. Like, this is the punchline. You should be able to do it mathematically, you should be able to do it graphically, and you should know the story. Right? And you should be able to say, Ivan gives us some goofy problem. I should be able to say whether that change makes the multiplier bigger or smaller without doing the math or anything, just by story. And the story is people buy more, fine, more stuff is produced, then what? And if that then what is big, if people change their behavior a lot, the multiplier is going to be big. And if that then what is small, people don't change their behavior much, the multiplier is going to be small. Okay? So when marginal propensity to consume is very small, people aren't changing their behavior much in response to new income, multiplier is small. If the marginal propensity to consume is really large, the multiplier is big because somebody buys something at my shop and I immediately go out and spend almost all that money. And that means someone else feels rich, and he immediately goes out and spends almost all that money. Someone else feels rich, and so it's a big effect. Okay. What do we got here? So in this story, in this basic story, and obviously this is a very silly, simplified model, but this basic effect shows up lots and lots of places. So in this sort of class of ways of thinking about the world, recessions and booms are becoming about because of this people are spending more, people are spending less. We've ignored potential output, and that's important, but this is the basic thing what we think that recessions and booms are coming from. So why do we go into a recession? People stopped buying stuff, is the story. And they stopped buying stuff, and that seems like a small thing, but in fact, through the multiplier, that had really big effects. They stopped buying stuff, so the storekeepers felt poor. They stopped going to the pub. The publican now felt poor. He stopped going on vacation, and so on and so forth, right? So it had a big effect, a ripple effect through the economy. So one of the sort of major issues in macroeconomics is we have these recessions and booms. Like some years are good and some years are bad. How can we make things more stable? Is there anything that we can do sort of as policymakers, which is sort of a broad thing, which includes governments and central banks, which we'll get to in the next chapter, and various other institutions? Is there anything we can do to make these recessions last less long and be less unpleasant and have less unemployment and all of that? What can we do to stabilize the economy? So there's sort of two big issues. How would we make the things better over the long period? So growth and that kind of thing. You can have too much growth too, but how do we make things better over the long term? But the other major issue, and the one that we're going to focus on in this class, is how do we stabilize these business cycles? Okay? And in this story, there's not really any way that we can get rid of business cycles, like the initial thing of business cycles, because we can see that it can be in people's heads, right? You just feel like next year is going to be terrible for whatever reason, bad TV show, bad meal, whatever. You feel it's going to be bad, you stop spending now. And so, it's not like a policymaker did something wrong. It's just that people got it into their heads that next year is going to be bad. Therefore, they stop spending. Therefore, badness comes already. Right? So the recession comes because we want it. It's a very Tinkerbell sort of way of thinking about the economy. We all should think the economy is great. And if we do believe in fairies, then there will be fairies and the economy will grow. And if we don't believe in fairies, then the economy will shrink. Right? Because it's all of us spending. If we stop spending, people are out of work because there's not enough spending to support full employment. Okay. So what we could do, though, we can't get rid of this, but we do have some control over this exogenous spending, this autonomous spending, right? Because government spending is in there. Right? So it's investment, and we don't really have control over that. That's sort of, people think next year is going to be great, they invest a lot. People think next year is going to be bad, they don't invest. We don't have control over our autonomous consumption. Same problem. But we do have some control over government spending. Foreigners, good Lord, we don't control them. But we have control over government spending, and we could maybe use government spending to stabilize the economy. So when we're in a boom, when autonomous expenditure is low, maybe we could increase government spending, raising autonomous expenditure back up. Okay. Okay, so we're going to have two types of stabilization policies, and this is just so that we're all speaking the same language. We have expansionary policies designed to expand the economy, and we have contractionary policies designed to get output lower. Okay. Now we haven't. Well, we have. I'll leave it alone. So I should mention that people, because of how we grew up and all of that, and the general press around us, we tend to think that, we would want output up and we would never want output down. But of course, that's not true, right? There's an ideal amount of output. We don't want everyone working 24/7 and slave labor and bulldozing the cities and all that stuff that would create lots of work, right? Because there's a cost to output. It's effort. It didn't just pop from the ground. So there is an ideal amount of output. So it could be too much. There's also some issues, and we haven't seen them, and we won't see them for, I think, 3 weeks or so. But we will see them in this class, where if output is high for a sustained period of time, it can cause other troubles. It will end up causing inflation, for example, and it won't. So there's troubles with high output, and there is reasons why you want to get output down. It just doesn't feel intuitive to most people going in, but you can imagine that we had an economy where everyone was slaves and we all had to work 23 hours a day. That would not be an ideal economy. So we would like to lower output below that level. Right? So just as a start. Okay? Forgetting the realistic troubles of even in our market economy, you can end up with high inflation because you've had output too high for too long. Okay. Okay. So there are times when we would like to avoid that. And in general, there's also this feeling that if we have a big boom, that means we're going to have a big crash. And there's a lot of empirical evidence for that. And so even if you don't buy the we don't want output too high thing, we also might want it to keep the booms from being too extreme so that we don't have the hangover afterwards. Okay. The whole Celtic tiger thing. Well, it was a thing. Okay. Before most of your time. All right. So we, broadly speaking, have two sets of tools to do this. Now, there's lots of things we can do, and there's lots of details of all the tools. But it's sort of in a broad brush, we've got two ways of going about stabilizing the economy. We can use monetary policy, which is going to be playing around with the money supply in a way that will take 2 weeks of lectures to explain. It's a fairly complicated chain of events that makes this happen, but it is a thing we can do. Right? So this is central banks, how they deal with the banking system. In principle, lots of arguments in macro about this, but in principle, you can affect output with monetary policy. And fiscal policy. And fiscal policy just means government budgets. So how much do they spend? How much do they tax? So we can do it through the tax and spend system. Okay. So focusing on fiscal policy, because that's what we've addressed so far. Like we have fiscal policy. And you say, where do we see fiscal policy in all this? We had the letter G. The letter G is fiscal policy. That's how much government spends. And we had the letter T. That was the tax rate. How much do we tax? Right? So those two things are fiscal policy. How much do we spend? How much do we take in government revenue? That's fiscal policy. So it's in our model. We actually have fiscal policy in our model. Even though it's a simple model, we got it. So we can talk about it. So that's going to be government spending. And government spending has a direct effect on planned aggregate expenditure, in the sense that, you'll remember, way back in the day, what is planned aggregate expenditure? It is just equal to C plus IP plus G plus net exports. Look, there it is, directly there. It's part of what we're buying, right? If you want to buy Irish stuff, the government can buy Irish stuff. And so it will directly affect spending. So if output is low, the government can go out and say, haircuts for all employees. And everyone gets a haircut. That puts the barbers back to work. The barbers feel rich. They go off to the pub, and so on and so forth. You get the multiplier effect. Lost me. Okay. The other thing we can do is we can change the tax rates. So we can change how much we're taxing. And this has an indirect on planned aggregate expenditure, right? Because look, no T. There's no T in there. And so where does that come from? Well, it comes from because C itself depends on T, right? If you'll remember, C was equal to C bar plus little c y minus T. Okay? And it's an indirect because if the tax rate changed and nothing else happened, nothing would happen, right? If government spending changes and nothing else changes, that is, the government starts buying haircuts, well, those haircuts are going to get produced because we got the barber shop where they cut whenever a customer comes in. The government guys come in, get a haircut, fancy haircut, and that's going to affect output directly. Okay? But here, if the taxes change, nothing happens, right? Now, in real life, it does, because when they come and they take more money from you in taxes, you feel poor, and therefore you reduce your consumption. And we can see this mathematically because, look, it doesn't show up here directly, but if the tax rate goes up, your consumption is going to fall by C times T. There's a minus CT. So it's going to affect your consumption, but it's indirect because it's going through your consumption. Okay? Nevertheless, it's still going to affect output because you're going to consume less because you have to pay more taxes. Therefore, you're not getting your hair cut. Therefore, the barber feels poorer, and so on and so forth. Okay. And lastly, we should mention transfer payments. Transfer payments are money that the government gives to people. Okay. So this is not part of government spending, you'll remember. Government spending is when you buy a good or service. So if you go out and buy a haircut for your Taoiseach, because God knows he needs one, then that is part of government spending. Okay? Maybe not wisely spent, but spent nonetheless. Government spending. But if you give your Taoiseach 100 euros, because good on you, man, and you give him 100 euros, that's a transfer payment, because it was a gift. It wasn't for a service he rendered. You just like the guy, and you give him a euro, right, and give him 100 euros. And I do the Taoiseach, obviously, because it's funny. But Taoiseach's always funny, no matter who has the job. Anyway, but we give it we give money to retirees. We give money to people with children. And there's various reasons, all nice policies. It's just not government spending because we're giving them money. It's not in exchange for a good or service. But nevertheless, they're going to feel richer, right? If you give them money, they're going to feel richer, and they're going to go out and buy stuff. But this is, again, an indirect effect on planned aggregate expenditure. It's because they change their behavior that we have the effect. And in fact, from our point of view, transfer payments, from a macroeconomic point of view, not from the individual point of view, but from our point of view as macroeconomists, transfer payments are just negative taxes. You give someone money, it's just the opposite of taking money away. Okay? Now, whatever the reason is that you're doing it, like good reasons, bad reasons, whatever, if you're not doing it, if you're not giving them money not in exchange for a service, but just because you think they ought to have some money, that won't directly affect planned aggregate expenditure, but it will make them feel richer, less poor, less destitute. Anyway, it'll make them, they have more income, they have more money, and therefore they can buy some stuff. And so it will affect planned aggregate expenditure, but only indirectly. Okay. And I actually like sort of browsing through this, but it is sort of an important distinction that people have a tendency to think about government spending and they just think government budget. But a lot of what the government spends is actually transfer payments, not in exchange for goods and services. You hire a fireman, that's in exchange for the fireman's services. But if you give money to someone without the exchange, that's a transfer payment. And it's really important for our purposes that we just, it's just negative taxes. Instead of taking money, you're giving money. It's really in the tax category. From our point of view, it's no different at all. Okay? There are, if we're getting into the micro and how people feel about the money and all of this, which is important, it's different. But from a macroeconomic point of view, it's not. Okay, I have to let you go. Yeah. Okay, so we'll do stabilization policies next time.